Hey guys, Miss Davis here. This is Unit 7, Skill 7 video, solving word problems with rational equations. So write down the essential question, how can we solve word problems using rational equations, so fractional equations. And after you've written that down, let's dive into question number 1. We're going to do some highlighting. So looking at example 1, says Melissa is working as a caterer at a wedding. She'll be paid a flat fee of $100 plus, so we're going to be adding a bonus of $600 that will be divided among the catering staff. Okay, so we see we've got a flat rate, which means it's paid one time, plus we're going to add, and then we're going to divide by the number of catering staff. So part A says write a function to calculate Melissa's pay, P of X, so that's going to go at the beginning of our equation, based on the number of caterers X. So we know that X equals the number of caterers, so that is what we're going to divide by. So our pay is going to be P of X is equal to that that 100 that gets paid once. So the 100 plus the bonus of the 600, but it's going to be divided by, so over X. Okay, so that's the original P of X equation. And so our next equation says how much will Melissa earn if there are 8 people catering the staff? So that what that means is we're going to plug in X equals 8 because X is the number of caterers. So we're going to find P of 8 and do 100 plus 600 divided by 8. And if you type that whole thing, this whole thing right here into the calculator and hit enter, we get P of 8 is equal to 175. Okay, so if there are 8 people working on the catering staff, then Melissa will earn $175. All right, and then the next one says if Melissa made $125, how many people were on the catering staff? So if we're finding how many people, we're finding X. So we're plugging this one in for P of X. Okay, so there's not much room here, but I'm going to use this equation to reference, and where P of X goes, so where this goes, we're going to plug in the 125 that they're giving us. So 125 equals the 100 plus 600 over X. Okay, so we're going to get X by itself, and the first thing we want to do is subtract that 100 to the other side. So I'm going to bring it back up here. We get 25 equals 600 over X. And then to solve for X on the bottom there, I'm going to put 25 over 1 and cross multiply. So I get 25X equals 600 when we cross multiply. Divide both sides by 25, and we end up with 24. So there are 24 people on the catering staff when she made $125. Okay, so the next part, I'm going to insert a video to show you how this equation is going to look on the graph, because it's not going to be easy to see right away. So you're going to have to do some zooming and changing of the window settings to see the graph that we need. And we want our domain to go from 0 to 30. So in the x direction, we're going to go from 0 to 30 on the x-axis. So here comes the video. Okay, so as you can see, I've jotted down some points from the table that are easy to plot, and going all the way up to 30, because our domain is 0 to 30. And I label the x-axis as the number of caterers, and then the pay as the y. So now we got to determine a scale, and looking at these blocks here, I would count up by twos, I think, to fit all 30 on here on the bottom. And then going up this way, we want to go up to our highest point is going to be 700. So I'm going to skip count and make each box worth 50, but put a label at every 100. So I'm going to go ahead and label this if you want to pause the video and do the same. Okay, so as you can see, I've labeled my x-axis counting up by twos to reach 30, and then my y-axis going up by 100s, but each block is worth 50. And then I've plotted my dots that I have from the table over here and connected the line, or the dots. And we want to look at the domain. On the right side, so see how it's got a less than or equal to? That means that we need a closed circle at 30, and since it's a specific domain, we don't go past that. So no arrows on the right on this side. But on the left side, do you see how the graph never actually hits the y-axis? That's because there's a vertical asymptote there of x equals 0. So we have to draw in a vertical asymptote, and that is the equation x equals 0 is one of the vertical asymptotes, or one of the asymptotes in general. Asymptote, okay? And again, that can be seen through the denominator when it's equal to 0, creates the vertical one. And then the other one, going left and right, is going to be from, oopsies, I thought that was the highlighter. It's going to be from the 100 here, that is that vertical shift. So we're going to draw in an asymptote going horizontally through y equals 100. So there's the horizontal asymptote. Okay, but as we approach the vertical asymptote, it never actually hits 0, and since we never actually hit 0 here, we're going to actually draw the arrow up and shoot up to positive infinity that way. Because again, there is an asymptote there, so it never actually hits 0, so we need an arrow going up. Okay, but closed circle and no arrow on the right side. Okay, so go ahead and flip over to the next problem. All right, so let's read through example number 2. Liam purchased a new snowplow for $1,950 and plows parking lots of a local business. Each time he plows a parking lot, he incurs a cost of $30 for gas and maintenance. So our first part is to write an equation representing the total cost, T of x, based on the number of parking lots, x, that he plows. So it's how much he's spending, not how much he's making. So the total cost, we're going to write it as T of x. Well, he pays that $1,950 to purchase a snowplow, plus he is paying $30 for gas and maintenance each time he plows a lot. So that's going to be times the number of lots, or just x. So there's our total equation for his total cost. Part B says write a rational function. So rational function is going to mean that it has some sort of fraction in it. Okay, to represent Liam's average cost. Again, thought that was the highlighter. Average cost, C of x, based on the number of parking lots he plows. So I'm going to write a little note off to the side that whenever we're determining average cost, so average cost is always going to equal the total cost of whatever it is, so the total divided by x. So it's always the total cost of whatever the problem is divided by the number of, in this case, lots, which is x. Okay, so it's your total divided by x, or whatever the variable is that you're dealing with. So our C of x is our average cost, is going to equal the whole thing, so this whole total cost divided by x. because you're basically adding up everything that he spent and averaging it or dividing it by however many total lots he has plowed at that point. So that's how you find average. You add things up and divide them by however many things are there. Okay, so that's the average cost. So if Liam charges $75 each time he plows a lot, how many parking lots must he plow over the winter so he doesn't lose any money? Okay, so they're asking us how many lots, so we're finding X because X represents the number of lots, and he's charging $75 each time, so that's his average cost that he is charging, okay? So his average cost, we're going to plug this in for C of X, so I'm going to plug it in over here on the left, equals, and then the right side, 1950 plus 30X over X. How do we solve this? Just put the 75 over 1, so we have a fraction equals a fraction, and cross multiply. So you get 75x equals, well, 1 times those two things is just those two things. So I get that. Oops, x. And then we're going to solve for x. So take your smaller x, move it to the other side. Get 45x equals 1950. Divide both sides by 45. Divide by 45. And we end up with 43.33 lots. But obviously we can't plow part of a lot. So we have to think if he plowed just 43. So I'm going to say this means if it comes out to a decimal that he either plows 43 lots or 44 lots. Well, if he plows 43 lots, he's going to be short of that because this means that he needs to plow a whole nother one in order to not lose money. So we're going to say total of 44 lots. Okay? All right, last problem. We'll go ahead and flip on over. All right, for our last example 3 here, it reads, Ethan takes 15 minutes. So we have Ethan taking 15 minutes and Jake taking 60 minutes for the newspaper distribution in Rosedale. How long would it take for both of them working together to distribute the newspaper in Rosedale? So let's take a step back and kind of think about what they're asking us. Is if we put both of them together, so we're going to add them together, how long would it take to distribute them to all the newspapers in Rosedale or to do the whole thing, which is a full job? Okay, so I'm going to write this out as Ethan. The time it takes Ethan plus the time it takes Jake is going to equal the 1 full job of distributing all the newspapers of them working together. Okay, so in these type of problems, if we have 15 minutes, we're going to set Ethan's time up as 1 over 15x. So it's like 1/15 of the time. And then Jake, we're going to set up as plus 1/60th x, okay, and equal to 1. Okay, so 1 again represents the full job. All right, from here, we used to have students find common denominators and everything, but it really is just easier to type this, or type 1/15 plus 1/60, or 1/60th, into the calculator. So type that right into your calculator and hit enter. It just saves mistakes from being made. So when you do that in the calculator, that gives you an answer of 1/12. Okay, so it's 1/12x, or we can slide that x up on the top of the fraction and set it equal to 1. And then from here, we're just going to cross multiply. Okay, so put the 1 over 1, cross multiply, and we get 12 equals x, or 1x. Okay, so it would take them 12 minutes if they worked together. 2 is better than 1 in this case. Okay, all right, go ahead and write your summary and then do your practice.